So welcome again. I'm Pavel Chmelař, Sales Director of GREYCORTEX. We are going to hold this webinar together with my colleague, Sales Engineer and Chief of our Cyber Ops Department, Michal Šrubař. This webinar was created by our colleague Marnix Janse, the OT Product Manager, who unfortunately cannot be here today. So this webinar we try to focus on being as practical as possible and leave general and marketing things to a very minimum. So it will be focused on the demonstration of the hacker's attack on a cookie factory. Let me just very briefly explain why we are able to do something like that. And why we chose the topic of network visibility for this webinar. So basically, we consider network visibility as crucial for two areas. One is cybersecurity of OT networks. By this, I mean threat detection and elimination and forensics, being able to find out what was going on. And then, of course, maybe the more important area of prevention of unplanned downtime. So we are processing network traffic. We support more than 90% of the networks so for example, we support communication of devices by vendors such as Siemens, ABB, Honeywell, Emerson, and so on. You can see examples of the protocol that we support in here. And even though we are able to do active device polling, like querying the devices for more detailed inventory information, and also we are able to process log from various OT devices. This webinar and this attack demonstration will be primarily based on a passive monitoring of network traffic that we got in our lab from a span port, a mirror port. And in here, let me hand over to my colleague, Michal.
Thank you, Pavel. Thank you for your introduction. My name is Michal Šrubař, and I will show you the demonstration of an attack on a cookie factory, and also how to investigate this attack using a tool of GREYCORTEX Mendel. For this attack, imagine that we have a cookie factory that has basically 3 locations. Those locations can be seen on this diagram. There is a first location, which is called offices. In these locations, there are employees, there are administrators of the network, sales team, marketing, management of the company, and so on. Then there is a second location, which is basically storage and bakery of ingredients that are used during the bakery of the cookies itself. And then we have a third location where there is a packaging and logistic of the cookies. So they are basically packed into the boxes and they are shipped to the end users and consumers. All those locations are somehow connected between each other. They are connected using also the IT networks and also the OT networks, because on both of the locations there are machines that are used to prepare the cookies and help the process of creating the cookies and shipping them to the others. In this demonstration, there has been an attack on this cookie factory. And this attack has been already done. So we will use our tool called GREYCORTEX Mendel to investigate this attack. And I will show you the capabilities of the tool for this investigation. So let me now switch to our application, which is called Mendel. I will use this link, which will redirect us directly to the Mendel and directly to the events that happened during the attack. Right now, we are looking basically at the time interval. So you can see that the attack happened on the Monday, 8th of this month. And as you can see, this attack has been performed shortly after midnight. And as you can see, our tool has detected a lot of events during this attack. And what we will do right now is that we will go through those events, and I will try to demonstrate and show you what exactly happened during this attack using Mendel. So as you can see from the timeline, the attack was long about an hour, and there has been about 15 events detected by Mendel during this attack. We will go from basically left to right, so we will see what happened from the beginning to the end, and we will start with the events at the beginning from the severities with higher severities. So as you can see at the beginning, there are some events with prefixes exploit. Those are saying to you that there has been some exploit used on the network. And from the name itself, we can see that there was a exploit called Eternal Blue used, which was basically financed by American NSA, released or leaked by shadow brokers. This one is actually quite famous. And we will have a look at some details what was detected. So let me click on the first event. And as we can see, as Mendel is saying, this exploit was triggered during the communication of some device from the Wi-Fi network to the Awesome Bakery office VLAN. And it was triggered on the port 445, which is typically used for the SMB protocol. So let me now have a look at the details of this network communication. And we'll select, for example, the first occurrence. And as you can see right now, we got into the flows, which means we are looking at the network flows. And these particular rows are giving us the information about the network flows. So for example, the first row is telling us that the device from the Wi-Fi network has initiated a communication to a device in the Awesome Bakery office, and it was using the SMB protocol. From here, we can see that the tool is showing us the information from all the network layers. So we can get the information from the application layer, transport layer, the network layer, and possibly the link layer. The most interesting here is probably the application layer, because in here we can see the detailed information from the SMB protocol. That means the transactions that were happening between those two communicating devices. If you are a bit familiar with the SMB protocol, you will probably know that there has been some trying of session setup. And at the end, as we will look, it was successful. For example, in here, we can see that the adversary was trying to connect to the IPC SMB share, and we can see that it was successful. And it was using the SMB1 version of the protocol. So as you can see, the adversary was able to successfully connect to this Windows machine. So he was basically able to get to the engineering workstation that was running Windows 7. If you're asking why Windows 7, it's because of compatibility reasons of the software that is used on the machine to control or handle the devices that are on the other locations that are using the SCADA protocols for communication. So let me get back to Mendel. And what happened here is that the adversary got an access to the engineering workstation over the public Wi-Fi that is in the office location. So the adversary got access to this machine, and what was happening next? we can see that there is some port scanning behavior. And as we can see, this port scanning behavior is happening from the device that has been infected. That's this device in the bakery office VLAN. And we can see that the scanning activity was happening to the other two locations. We can see that the scanning was happening to the storage and preparation side and also the packaging and logistics VLAN. And we can also see that the Modbus protocol was used during this scanning. So let me show you some details from the network communication. Maybe not this one, but this one will be better. As you can see, there is the infected device, and you can see that this infected device was trying to connect a lot of different IP addresses, and it was trying to reach the port, the destination port 502, which is typically used for the Modbus protocol. As you can see from most of the communication, there was just SYN packet sent to the destination IP address. So the adversary was trying to initiate the TCP connection using the TCP handshake, but it wasn't successful in those flows that we are looking at right now. So let me sort those flows using the destination packet count, so we can see if there are some successful connections. And we can see that there are not. There were some devices that responded with ECK reset, but the adversary didn't find any open device on this network. So let me have a look at the other one, the packaging and logistics. And let me do the same operation. Let me sort them out. And it looks like there aren't any other ports open either. So this basically is giving us the information that the adversary was trying to search what's around him. He was able to discover that there are other two VLANs because some devices were replying back to him for his scan. And let me now show you what was happening next. As you can see from the table, there are some events saying or giving us some information about setting new temperature and also changing non-default amount of cookies. So let me have a look at them. The first one that we will have a look at is the change of the temperature. This event is giving us the information that the value of the temperature that is set for the oven that is making or baking the cookies has changed somehow. So let me show you some details about that. Let me again have a look at the flows. And as you can see, there is a connection from the infected engineering workstation to a device in the storage and preparation location. And as you can see, this network connection was happening using the Modbus protocol. And as you can see, we can see some information in the application layer. And as you can see, for example, there is a property called value. And this property is basically setting the temperature of the oven that is baking the cookies. So what happened in this network flow was that the adversary was able to connect to the oven using the OT network, and he was able to change and play with the values of the temperature of the oven itself. So basically what happened is that the adversary was able to connect from the infected engineering workstation using the Modbus protocol and connect to the oven itself or the controller that is controlling the temperature of the oven, and he was able to messing up with the temperature itself. Let's get back to the list of events, and let's have a look at the second one, which is giving us the information about changing the default amount of cookies that are packed into the package. Let me again show you the flows. And let's have a look what was happening there. As you can see, again, there was a connection from our infected engineering workstation. And this time, the adversary was able to connect to some other device that is in packaging and logistics side. And as you can see, it was again performed by using the Modbus protocol. And as you can see, again, we have the information from the application layer, from the Modbus protocol itself. And as you can see, the syntax is very similar. There is some information about what register we would like to write the value and what is the actual value that we want to write down. So as you can see, this register number 2 is basically handling the number of cookies that are put into a single package. And as you can see, the adversary is changing the value to 8. This was detected because the default and setup value by the administrator is 10. So the system is giving us the information that somebody changed this value. And that's the reason why Mendel basically is alerting you about this kind of behavior. So what happened here is basically that the adversary also got access to the machines on the second location where there is packaging and logistics. He was able to set the different values of the machines that are packaging our cookies. So he was able to change the number of cookies that is put into a single package. That means that the adversary was able to connect to both of the machines on the remote sides. He was able to abuse the Modbus OT protocol to communicate with them and also to change the values of the properties that they have set. And that means that the adversary is basically able to change the flow of the processes that has been set up by default on those locations. I think there are also some other events that has been detected during this attack, but those are probably not that interesting. The most interesting are those that are giving us the information that something has changed on the OT network, and also that the engineering workstation got infected from the public Wi-Fi that is on the office location. So I think that will be all from the demonstration part. And now let me handle this presentation back to my colleague Pavel. So please, Pavel, can you handle that?
Thank you, Michal. Let me contribute with a couple of remarks. So, of course, Mendel is not deployed in the network so that you can analyze some previous successful attacks as Michal did. It is there to alert you in early stages that something strange or upfront malicious is taking place. And of course, either automatic action triggered by Mendel or a manual action can or should be taken. I mean, why we are facing with a situation, or we can face with a situation like this, one of the reasons, and maybe one of the primary reasons, is that OT protocols, they have minimal security features, and this is not by chance, this is intentional. It is minimum security by design, because we need these devices to work without any interruption, so we don't need any CPUs or antiviruses or anything on them. And the manufacturers or the vendors of these devices are mentioning that OT networks and these devices are to be protected by, let's say, a complex combination of measures, policies, both from the area of OT and the network or IT itself. And I think all of you have seen some kind of recommendations or documents or best practices from organizations such as US NIST or European ENISA. And what's important that these recommendations are gradually, or best practices are being translated into laws. And for example, this is what we have seen in the past couple of months in the US, and for example in Germany, we can see increasing penalties and also added personal responsibility of the management of the companies. Yes, this is I mean, the situation of course is often more colorful, and despite this, it's clear that not all organizations can put all these requirements into practice. And GREYCORTEX Mendel is to help there. It can support both, I mean, virtual blue teams in the organizations that, let's say, do the work as Michal did, analyzing problem and trying to prevent this in the future, or the red teams, which are mostly outsourced to external organizations. And as I mentioned, GREYCORTEX Mendel is primarily designed to help both teams. Why there is GREYCORTEX for industrial networks? Because there is a lot of competition around. So we took a bit different approach. We designed GREYCORTEX as, I would say, like one of the best first steps for industrial network, for their security monitoring, and also a solution that it's easy to implement and operate, and that grows with the customer. Now, we design it so that it can be managed by small teams with small budgets and being able to simple to use. But it's not just that. It's not just for organizations that are starting with OT security monitoring. It's also an excellent tool for organizations with structural teams or higher level of cybersecurity. And for example, I can mention that it is a very great and valuable complement for other tools. For example, if SIEM solution is already implemented. Also, one of the differentiating points that our GREYCORTEX Mendel is both being able to handle IT, OT, and combined environments. And one of our aims is to be the tool that is used by both OT and IT and security teams together. And we aim to improve collaboration between these teams if they are in the company, because this is often what is lacked. And in the end, we aim at empowering IT security people do OT security, because there are very few people on the market that understand both cybersecurity and OT networks. And from the verticals or in industries, we are prioritizing processing, manufacturing, and industry 4.0 together with energy and utilities and healthcare. Of course, we are covering also some other use cases. I can mention, for example, maritime and shipping industry. So primarily, GREYCORTEX is a vendor of a platform, and then it can be used for various use cases. I'm mentioning 3 in here. The smallest, or the easiest, is something that we can call network asset inventory scan. This is something that can be done in one location pretty fast, in minutes to hours, and basically it's a snapshot of the network, and the black box network can become much brighter so that you see what devices are there. You can see the vulnerabilities and so on. Another step, or let's say more complex, are one-off or repeated security audits that take several weeks to 1 month. And apart from providing a snapshot in the asset inventory, it also shows you more information about the behavior of the network, and also the related risks and violations or compliance with security best practices or internal tools. And finally, of course, it is being used, and it's aimed to be used as a security monitoring tool, both as an internal tool, and both as a managed service for our channel partners. Of course, we do some consultancy services ourselves. I can mention, for example, that we have 3 laboratory environments. Apart from this cookie factory, we also have a water plant and the energy distribution network that can be used by our customers and by our partners. Also, we are helping with designing, let's say, special detection methods or custom signatures and so on. Just very briefly, apart from this passive monitoring, we also offer the capability of asset discovery. I already discussed this very briefly, so by this you can get deeper insight into what assets are in the network and if there are any problems with the supply chains, critical vulnerabilities, and so on. And we have this integrated in Mendel, and we also have a standalone asset discovery appliance that can do this alone. And finally, GREYCORTEX, this is something that we have not shown today, but GREYCORTEX Mendel is also a great tool for policy monitoring, whether digging very deep all the way to the application level data, for example, if some certain values are in certain ranges, but also on a higher level, for example, what devices are communicated with what devices over what protocol, what is the frequency or how often, and so on. And again, going up, of course, you can see what if there are changes in the network in general, like new communications or new devices, or the network changes bypassing OT perimeter, and so on. I can also mention very briefly incident management and automated response as another area of capabilities. And let me close this session now and leave the floor for your questions. Okay, I can see a couple of questions in the Q&A, so let me address that. The first one, the incident. Hope we will have GUI mode step-by-step flow. Then we will be able to follow the incidents properly and easily. I'm not sure I understand that. But I mean, there is a workflow, and then on that you can trigger either manual or automated action. But I'm not sure if this is the answer to your question. So let me maybe ask the author to rephrase it if needed. Another question about the presentation. Yes, it will be shared. Another question, maybe this will be for you, Michal. Would it be possible to prevent the attack with an industrial firewall?
Well, if there would be an industrial firewall, that would be between the engineering workstation and the machines that were on the other locations, that wouldn't be probably much helpful for the changing the values, because the engineering workstation itself is meant to be able to control those devices. So if basically the attacker gets access to the engineering workstation, then he should be able to do the regular changes. Where the firewall could help would be between the communication of the attacker from the Wi-Fi network and the engineering workstation. That's the place where a firewall could help.
Okay, thank you. Then we have a question about the difference between GREYCORTEX Mendel and other vendors. The author mentions Clarity and Nozomi. So of course, there are many traditional, let's say, or grown startups in the OT security or DPI monitoring or industrial IDS arena. We including Nozomi and Clarity. our use case is primarily what I mentioned, that we are aiming at being low footprint and affordable tool for including like mid-sized companies, including, for example, public utilities and so on. So affordability and ease of use is one area that we are competing with them. The other on the other side is that we are going deeper into the protocols, mostly all the way to the application data, and so in this case we can cover some use cases that they are not always able to do. Also, the interoperability between IT and OT environments is one area that is an advantage in case of us. But I'm not telling that Clarity Nozomi or others are bad products. Of course, in several respects, they have more mature capabilities, and they are covering some use cases that we can't. But we aim to cover several use cases that we talk about better than them. Do you have a list of protocols that will be supported in 3.8? Yes, this is part of the presentation. It was, and we will send the presentation to you. I think there are two protocols marked with a star. This means that we are recognizing 3.8 version. So I don't see any other questions now. Feel free to ask them. Of course, feel free to contact us directly in case of any questions. Not sure if today or not sure if this week you will get the present, maybe early next you will get the presentation together with the recording of this webinar and the list of questions with the answers. So thank you very much for your attention, for your attendance, and I hope we'll meet or see you on some other webinar. I guess this will be early next year. So thank you very much. Also, thank you, Michal, for your demo, and have a great day. Goodbye.